Now you can think about the progression of the arch in different phases through history by thinking of three different basic geometric shapes and how these led to different solutions for the problem of opening up a space in a wall for a door or a window or something like that. So the first most obvious shape that you see in the ancient world is based on a square, right? So one side of the square is basically the ground. The other two sides are what they call the posts and lintels. So this is the most ancient kind of construction method that we find in the ancient world. Post and lintel. So you have two posts, one on either side, and sitting on top of the posts, you have what they call a lintel, which is basically a horizontal post. So the post and lintel, very simple, very effective in a limited way. And the limit is that the more weight you pile up on top of this lintel, of course, gravity is going to pull all that down, and eventually in the middle of the lintel here you're going to get strain. This is going to begin to crack, and it's going to want to fall down in the middle of this post and lintel. And so this is a simple solution, it's an effective solution, but it's limited in what it can do, how much weight it can actually hold. So the next shape that the Romans made use of was the circle. And if you've looked at this sort of thing, maybe done some experiments in engineering and science class or something, you know that the circle is a stronger sort of structure than you would find the square to be if you're trying to put weight on top of it. So based on the circle, the Romans came up with this half-circular arch sitting on the lintels or piers, and would build this in stone. And because they've rounded that shape out, this downward force, which is always there, of course, if you're piling material on top of this, is redirected outward this way and down onto these posts. There's still a good deal of downward force here, but it is being redirected. And so this becomes a much more efficient system for building and stacking up material on top of that. So it's stronger, you can build higher, and you can use less materials than if you're using that square shape with the post and lintel. So that was a very effective solution for a long time until we get to the Gothic age. Now the Gothic architects want to do something really revolutionary, and this is basically Bishop Suger was the one who was inspired with this idea at first, wanting to use as little material as possible to build the walls of these cathedrals so he could open up large spaces for windows, for stained glass windows. And so the solution that they came up with, which they may have borrowed from the East, you know, from Arabian lands, maybe at the Al-Aqsa Mosque and places like that. This arch is not based on a square or a circle, but on a triangle. Now, if you know anything about engineering, you've tried any experiments in science class or something, you know that a triangle is very stable and very strong. At this apex, it can take a lot of weight, and the weight is sent down this way. So based on a triangle, you have the structure of the Gothic arch. The architects basically, mathematically, they used the two lower points of the triangle, each one to draw an arch this way. An arc, I should say. And this one would be drawn in the other direction. Now this is not perfect because I'm not using a compass. They'd have two arcs coming together here at the point of the triangle, and this again proves to be even more efficient than either the post and lintel or the Roman rounded arch. because this business of directing the weight down starts earlier. You've got this point, almost like the prow of a ship, that's supporting this weight and directing everything down and to these piers. And this uses even less material, opens up a bigger space, and allows you again to build higher, which architects were always interested in, building higher and higher. So 3 different kinds of solutions to the problem of openings in the walls, 3 different geometric shapes.